Have you ever wondered how polymorphism works in APIs? Well, if you've been scratching your head over this, you're in the right place. Let's dive right in and unravel this complex yet fascinating concept. At its core, polymorphism is an object-oriented programming principle that allows objects to take on many forms. Picture it as a shapeshifter, like those we see in fantasy movies. It can morph into different forms depending on the situation, and that's precisely what polymorphism does in programming. It allows an object to take on many forms, providing a means to perform a single action in different ways. Now, why is this important? Well, polymorphism is a critical concept in programming because it helps increase the flexibility and interactivity of programs. It allows a single variable to control different object types, and a single function to use objects of different types as parameters. Sounds cool, right? But let's not forget about APIs, application programming interfaces, the unsung heroes that allow different software to communicate with each other. They are like the waiters of the software world, taking your request and bringing back the desired response. So, how does polymorphism come into play with APIs? Well, polymorphism allows APIs to use different objects and classes interchangeably. This means that an API designed to interact with an object of a certain class can also interact with objects of any subclasses. This versatility is what makes polymorphism such a vital concept in APIs. In essence, polymorphism in APIs is all about flexibility and adaptability. It's about being able to handle different types of objects, allowing for more dynamic and interactive programming. It's a game changer, a tool that can take your programming skills to new heights. Polymorphism in APIs is a fundamental concept. Understanding it could open up new possibilities in your programming journey. So let's delve deeper into this intriguing world and discover how we can harness its power. So, what exactly is polymorphism? It's a term that comes from Greek where poly means many and morph means form. So, in the simplest terms, polymorphism is the ability of an object to take on many forms. But why is this important in programming? In programming, polymorphism is a core tenet of object-oriented programming, or OOP, allowing objects of different types to be processed through a single interface. It's a concept that allows programmers to send the same message to different objects and get different appropriate responses, providing a way to simplify complex code structures. Let's dive a little deeper. There are two types of polymorphism, static and dynamic. Static polymorphism, also known as compile time polymorphism, is where the response to a function is determined at the compile time. It involves method overloading and operator overloading. Method overloading is where we can have multiple methods with the same name but with different parameters, and operator overloading allows us to redefine or overload most of the built-in operators available in C++. On the other hand, dynamic polymorphism, also known as runtime polymorphism, is where the response to a function is decided at runtime. It involves method overriding, where a subclass provides a specific implementation of a method that is already provided by its parent class. To illustrate these concepts, imagine a music player. The play button serves as a single interface, but the actual function it performs can change based on the file type. An MP3 file would invoke a different method than a WAV file, for instance. That's polymorphism in action. Remember, polymorphism is all about one interface, multiple methods. It's the backbone of API flexibility and scalability. It allows programmers to use objects of different types interchangeably, making code more flexible and easier to manage. It's like having a universal remote control that can operate your TV, stereo, and DVD player, all with the push of a button. But instead of electronic devices, we're working with data and functions. Stay tuned as we delve deeper into polymorphism and APIs in our next section. Now let's delve into how polymorphism works in APIs. Imagine you're at a vending machine. You press a button for a beverage, say a cola, and out it comes. On another day, you press a different button for an orange juice. And voila, you get an orange juice. Here, the vending machine is an interface that provides different drinks based on your choice. This is a simple analogy of how polymorphism works in APIs. In the context of APIs, polymorphism is the ability of objects to take on many forms. The most common use of polymorphism in APIs is the ability to create a single interface that can accept and return different object types. For example, consider an API that deals with shapes. The API may have a method called drawShape. When drawShape is called with a rectangle object, it draws a rectangle. When it's called with a circle object, it draws a circle. The same method, drawShape, is performing different tasks based on the type of object it is working with. This is polymorphism in action, but why is this useful? Well, polymorphism simplifies code and makes it more efficient. Instead of creating separate methods for each shape, we just need one method that can handle all. This not only reduces redundancy but also makes our API more flexible and easier to maintain. Furthermore, polymorphism allows for scalability. As our application grows and we add more shapes, we don't need to modify our API significantly, we just create a new shape object and our existing draw shape method can handle it. Polymorphism is like a Swiss Army knife in the world of APIs. It allows one interface to carry out a multitude of functions, making it a versatile tool in any programmer's toolkit. It's about doing more with less, about creating flexible, adaptable systems that can easily handle change. With polymorphism, APIs become more flexible and scalable, adjusting to different needs and situations with ease. You might be asking, what are the benefits of using polymorphism in APIs? Well, let's dive into that, shall we? First off, polymorphism promotes code reusability. Imagine having a toolbox where every tool can only perform one specific task. You'd end up with an overflowing box, right? But what if you had tools that could adapt and carry out multiple tasks? You'd have a much leaner, efficient toolbox. That's exactly what polymorphism does for your code. It allows you to create a piece of code that can be used in multiple ways, reducing redundancy and making your code cleaner. Secondly, polymorphism brings about a high degree of flexibility. It's like having a Swiss Army knife in your coding arsenal. With polymorphism, your code can handle various data types and perform different operations, depending on the input. This means you can write less code, yet achieve more functionality. It's like a chameleon, adjusting itself according to the requirements of the situation. Third, let's talk about scalability. As your system grows, so does its complexity. Polymorphism allows your API to easily scale with that growth. It enables your code to handle new classes and methods without requiring extensive modifications. So, as your project expands, polymorphism helps keep it manageable, maintaining a smooth operation. Moreover, polymorphism contributes to cleaner, more efficient code. It allows different classes to be treated as the same superclass, improving the organization of your code. It's like having a well-organized bookshelf where all books are sorted by genre, but each book still retains its unique characteristics. Finally, polymorphism can make debugging and testing easier. By reducing code complexity, it becomes simpler to identify and fix issues. It's like having a well-lit room where you can easily spot any misplaced items. In short, polymorphism in APIs allows us to create more adaptable and efficient systems. It's a powerful tool that helps us write code that's reusable, flexible, scalable, and overall more efficient. It's a game changer in the world of programming, and once you start using it, you'll wonder how you ever managed without it. So, we've learned quite a bit about polymorphism in APIs, haven't we? We've journeyed through the realm of object-oriented programming, unraveling the concept of polymorphism, this powerful ability of an entity to take on many forms. In our digital world, where APIs or application programming interfaces are the bridges connecting different software systems, polymorphism proves to be an indispensable tool. Let's take a quick stroll down memory lane. We started off by understanding polymorphism, this cornerstone of object-oriented programming that allows objects to behave in multiple ways, depending on their data type or class. It's like the chameleon of programming, adapting and changing based on what's needed. Next, we delved into the heart of our discussion, polymorphism in APIs. We discovered how polymorphism allows APIs to handle requests and responses in a flexible, efficient manner. It's the secret sauce that enables APIs to process different types of requests, each with their unique requirements, in a consistent and predictable way. We also explored the manifold benefits of polymorphism in APIs. The increased flexibility, the enhanced readability, the improved maintainability, and the ease of scaling. It's like having a Swiss Army knife in your programming toolbox, ready to tackle any challenge with grace and efficiency. However, we also acknowledge that with great power comes great responsibility. Polymorphism, while powerful, can introduce complexity and potential confusion if not used judiciously. It's like a powerful sports car, thrilling to drive but requires skill and caution. As we wrap up, remember this: polymorphism is not just a programming concept, it's a mindset, a way of thinking about problems and solutions in a flexible, adaptable manner. It's a testament to the beauty and versatility of programming and its endless potential to create, innovate, and solve problems. That's a wrap on polymorphism in APIs. I hope this journey has been as enlightening for you as it has been for me. And remember, the learning doesn't stop here. There's a whole world of programming concepts waiting to be explored, and I'll be there to guide you through it. So hit that subscribe button, because you won't find me later.